You're setting high expectations for this presentation, but let's see. Okay, so the topic that I submitted for this conference was redefining Android app development. And that was before Google I/O. Alec asked me to come and present, and I said, okay, I will, but I can't tell you what it'll be about. Well, now that I/O is over, the presentation actually changed a bit, because the thing I wanted to talk about was how we were defining Android app distribution. And obviously, this is about the Android app bundles that we announced at I/O this year. But before we get there, for those of you who maybe haven't been programming for Android for 10 years, I just wanted to present a quick history of all the technologies and all the things in Android and on Play Store that led us to this moment, to this new distribution model that we have from this year. So APK, when I started this presentation, I actually had to look it up. For 10 years, I never realized this means application package kit. It was never needed, so we always said APK. But that's the format that we used on Android always. And it hasn't changed a lot over the years. So it has resources from your app. It has the manifest. They are actually compiled into a slightly different format than XML. It's a binary format that's more optimal for loading at runtime. But it contains basically all the layouts and languages and drawables for all densities and device sizes and so on and so on. And then any assets that you put in there. And then we also have the code. And code comes in two flavors. So we have the DEX files, which are basically your Java or Kotlin code compiled into bytecode, into DEX bytecode. There can be, of course, many of them because of the infamous multi-DEX, DEX limit, which leads to using multi-DEX. And then we have the native libraries, which are put under the lib folder. And they can also come in many flavors for different CPU architectures. So if you have an app that supports ARM and ARM64 and x86, you have many folders there and many files. And only a small set of them is used on any device, right? Because a device is x86 or ARM, not both at the same time. Although that's tricky as well, and I will talk about that later. And then we have some metadata in the meta.inf folder, which I will tell you about in a little bit. So like I said, this has been with us for about 10 years. It hasn't changed a lot. Everything is still there like it was from the beginning. And there's really little space for change in this format if we want to keep backward compatibility. But there are things that we can do. And that's why also we're evolving this. So if we look at the resource table, like I said, in a typical app, you have resources for all kinds of devices. And this is just a small snippet of the drawables. So even if in a simple app, if you pull in, let's say, the support library or something like that, or any dependency that has drawables, they will usually be supplied for all of these densities, right? But your device only has one screen type, one density that it will use. So all that extra space in the resources table and in the resource folder is essentially unused, but it's still packaged with your app. And you're only using this small part. And what most people don't even realize, these empty spaces in the resource table, they also take up space. So even though there are no resources defined there, it still takes some space just to hold the nulls in there. So it's not ideal. And it's the same thing, like I said, with native libraries, with languages, and so on. So could we optimize an APK automatically without developers having to do anything? Well, theoretically, we could remove some stuff from there. So we could just remove the folders that are holding the native libraries that are unused on a specific device. We could try to remove drawables. But then we would have to edit the resource table, and we would also have to edit it to remove additional languages. And actually, strings can weigh a lot. Like in modern apps, in big apps such as the big apps from Facebook, Twitter, Instagram, like all of these big, huge apps have a lot of strings. They have a lot of features, a lot of translations. And we always think that it's the drawables that take up the most space, but it's actually languages that can contribute to it a lot. And that's a problem. So could we do that? Well, theoretically, yes, but there is a security model on Android where all apps have to be signed. And app signing version 1 has been with us also since the beginning of Android. And basically what it does is there's a file under the meta.inf folder that I mentioned that lists all the files in the APKs and their hashes, and that list is cryptographically signed by your private key that you as a developer have on your development machine. And so you sign it, and then no one can change it. I mean, you could, but then you can't re-sign it with the private key, and whenever someone tries to update your app that is not signed with the same key, it will just not work. So that's basically the security model of updates. Play cannot deliver an APK to your device that's not signed. That's the first thing, and it cannot update an app to an APK signed with another key. So one thing that's important here is that these keys are usually generated by you. They're self-signed. The apps are self-signed. The certificate is generated by you. So if an APK is signed, and even if the certificate says it's, let's say, from Wojtek Kalicin's key signed by Google, that doesn't actually mean it's from me and it's from Google, because anyone can type anything in the cert. It's, like I said, you're generating it. You can put whatever you want in there. However, if you get an app from a reputable source, like if you download it from Play Store, from the Google account, and it's, let's say, the Gmail app, then if you get an update and it's still signed by the same certificate, you can be sure that it's coming from the same person. So that's the model of signing that's been on Android since the beginning. And maybe one remark, like, could we optimize APKs automatically? Well, at some point, signing v1 actually allowed us to remove some stuff. So we could, let's say, delete the native library folders that we're not using. However, that loophole was closed because it was actually a security issue. So now, not only all files have to have the same hash as in the list, also all files have to be present. So that was closed way back, I think, in Android 2 or something. Okay, but there is a way. So could we deliver APKs that have been pre-built to match a specific device? We could. Play Store has supported uploading multiple APKs, or multi-APK in short, for a long time. And so we could build specific APKs for different screen densities. And so there are many more densities than that, but just to simplify, let's say we have 4. But then if we have native libraries, now we get 2 dimensions, so we have to take care of twice as many or 3 times as many APKs. And again, we already have 8, but if we count like 7 densities and 4 CPU architectures, then it would really be 21 or more. And then let's say you decide to drop support for some things on older Android devices, or add some new things from newer Android devices, and you want to maintain 2 versions of your app for some time so that people with older devices can still use it, and then people with newer devices get a better experience. So you essentially double the number of APKs you had right now, and that's not ideal. You have to manage all that. You have to generate it. And then there's even more filters that Play Store could apply. So for games, it could be, for example, different texture formats for different GPUs and different OpenGL versions. So that's really difficult to keep track of. And that's not all. I mean, every APK that you upload to the Play Store has to have a different version code. And so for across all these dimensions, you have to figure out a versioning scheme. This is an image from our documentation of one example of a versioning scheme for different API levels and screen sizes. But then if you get more dimensions, you need to manage that in a more complex way. And then there are things like if your device supports 2 or more APKs, the one with the highest version code is selected. Super difficult. Not a lot of developers did it. Even though we added this way in Android Studio of easily building multiple APKs. So it's called splits, and I added the quotes for a reason, which I will explain in a bit. So if you use splits, you can automatically generate multiple APKs based on ABI and density. ABI is like a CPU architecture. So it generates all these APKs for you, but you still have to come out with a version code, versioning scheme, and do that by hand in some kind of script in your Gradle files. So why splits? Well, because splits generates multi-APKs, but because of the name for the Gradle directive that was chosen, most developers started calling multi-APKs split APKs, which is completely wrong, as the rest of this presentation will show you. Now, splits are actually only generated if you add this undocumented, until now, directive called generate pure splits, which in addition to generating density and ABI splits, can also split by languages. But the reason this was undocumented is this was never actually supported by Play and Android in general. So this happened sometime in 2015 when I joined Google, and my manager came to me and said, so there's this new thing in Android Lollipop 5.5.0 called splits, and can you like tell developers about it? Like, it can decrease APK size if you split by languages, and that was not possible before. I was like, yes, new project. As a Noogler, I'm going to tell people about new stuff. So I went to the Play folks who are in the same building in London, and I asked, okay, do you support the new splits thing from Lollipop? And they said no. And I was like super excited. Will you support it? And they're like, not now. No, we're not supporting it. And a year passed, and I was like, oh yeah, what about this splits thing? It sounded pretty cool. So what happened to it? Will you support split APKs? And Play said no. And I was like, well, when will you support it? And they said, someday, we're busy. Well, that's not exactly how the conversation went. But in truth, they were busy on other stuff. There were other priorities, and splits were not a proven technology back then. We didn't have a good story for developers to actually deliver language splits to devices. And that's mostly because, you know, things like density or CPU don't change in a phone, but languages do at runtime. Like, you could have an app running, go to your settings, change a language on your phone, and what happens then if you only have, let's say, the English or the Polish split installed? So that was a difficult problem. But to be fair, the Play people were pretty busy. So in the 3 years that passed, they also said, like, here, have this. Like, you can now use alpha and beta tracks to test your apps with an open or closed group of people, of users. You can have stage rollouts, so you can start rolling out your app to, let's say, 25% of devices and test it out. You know, they added experiments, so you can test your icons and description text. You can have app campaigns for your app across all the different Google properties. They introduced new compression methods to make initial downloads of your app smaller. And then they figure out crazy, crazy stuff when it comes to diffing from one version of your app to another so that updates can be super small. They added a pre-launch report. So whenever you upload an app to the alpha or beta channel, we run it on, let's say, 10 devices and tell you if any crashes or if any other problems occurred. And you can go and see exactly what happened before you actually roll it out to users, so you can identify any errors early. And lately, we also added Android Vitals, which tell you about all kinds of performance problems in your apps, battery problems, rendering, a lot of stuff that you can, you know, it's not easy to test if you only have, let's say, 5 devices in your company, among your developers. But with Android Vitals, you can test it across all the devices that your users are using your app on. And that's not even all. So yeah, they were kind of busy, and they were trying to make the Play Store and the Play Console the best they could for developers. But then, at some point at Android Dev Summit 3 years ago, we also introduced Android Studio from the 2.0 branch. And it had this thing called Instant Run. And at first, it was a bit complicated how it worked, but I think around 2.3, there was a note added in the release notes that now whatever you change in your app, when you deploy it to the emulator or a connected device, we only dex and package the code that changed, and we use splits to push only what changed to the device. So this is an implementation detail, but I'm only mentioning this because I think this was the first actual citing of splits used by developers, even though you didn't actually interact with the split APKs, but that's what happened behind the scenes. So to push the smallest possible incremental change to the device while developing, they were actually pushing splits. And So they started finding bugs. They started fixing them in the framework so that splits can work better. And meanwhile, about the same time, app size started becoming a problem. So more and more developers were coming close to the 50 megabyte limit on the Play Store. And at some point, it had to be raised to 100 megabytes because it was not feasible to make apps as complex as they are these days with just 50 megabytes. And also, a lot of developers started being more interested in actually reducing APK size. I put out a lot of articles. I went to conferences to talk about it. And a lot of developers were very receptive to it and wanted to make their apps smaller. A smaller app means faster loading, faster runtime, and also, in some countries, and actually everywhere in the world, we still get devices that have very, very small storage. So it's important to have a small app. And then another thing happened. Developers started experimenting with actually not delivering the whole app in the APK, but rather dynamically pulling some parts of the app from a server somewhere. And using class loader hacks to basically inject the code into a running app, or even update part of the app without actually going through the Play Store. The problem was there was no officially supported solution. There wasn't even any good open source solution for that. And so everyone kept reinventing the wheel. And it's a little bit like reinventing cryptography, re-implementing your own crypto, which is not something average developers should do. And so many of these solutions had critical security issues. I'm not saying the top apps had security issues, but if some developer decided to do it without thinking about things like verifying the code that you actually pull down from a server before running it, or even pulling it down only through HTTPS. There are people who are actually pulling DEX files on HTTP so that anyone could inject any code they want into your app if they control the hotspot. So that was a problem, and we didn't want this to continue. But like I said, we didn't have an officially supported solution yet. Meanwhile, other things happened. Security was always a top priority, and so sometime during the past years, we introduced a new app signature scheme called V2. And instead of actually going through all the files in the zip file, in the APK, and generating hashes from their uncompressed contents, this just took the whole APK, went through all the bytes, and calculated the hashes from that. So it was stricter because it actually signed all the bytes in the APK. So it was safer. And it was also faster. Like the previous method to sign, but also to verify on the device, had to uncompress every file in the APK, and files could be pretty big, and then calculate the hash. Whereas this one literally just read the APK as is and could verify on the fly. The consequence of that was you couldn't change anything in the APK anymore, and it required a new tool. So previously we used the jar signer. For this, you had to switch to APK signer. If you're using the build tools from the Android toolchain, that was done automatically. But if you did any kind of post-processing on the APK, there were tools that were optimizing your DEX code, for example, that were run post-compilation. You would have to always re-sign it with APK signer afterwards. Also, new in signing, last year at I/O we introduced app signing by Google Play. And that was a big shift. It's still optional. I don't know if it will ever be required for everyone. But this was a shift from you as developers keeping track of your private key that is used to basically guarantee the security of your app, towards giving that key to Play for safekeeping so that Play can sign the apps on your behalf. Now, many developers were kind of afraid of that for many reasons, but the fact is, before we actually released it to developers, the Play team built all kind of safety measures and security measures so that no one could access your keys and actually sign the apps with it. And it's actually, in my personal opinion, it's actually safer if Play keeps your key and signs your app, because we did have incidents where big apps with hundreds of thousands of downloads simply lost their keys. The developer didn't keep a backup, or simply deleted the file, or someone bought an app and didn't get the private key with it, and they could no longer update their app on the Play Store. And so they had to lose hundreds of thousands of users because they basically had to create a new app listing. And there's nothing Play could do in this situation. Even if they came to us, even if they had a contact inside Google and said, please let us update our app, we lost our key, that is just not possible. Because the Play listing is one thing, but the on-device verification is another, and there was nothing we could do if an app is signed with a different key. So it would not install on the device. And so the other big shift was that for the first time since Google Play had the signing key, it could apply optimizations. It could actually change the APKs for you. And so we launched a beta of automatic APK optimizations at I/O. But I'm not going to talk about it a lot. It was a closed beta for some developers, and it was still based on the old multi-APK technique, let's say, where it would just generate a single APK that was tailored to the device it was installed on, and then deliver it to the device. It didn't use any of the split stuff. But around the same time, at I/O last year, we also released Google Play Instant. Back then it was known as Android Instant Apps. This is the brand name that exists now. So Google Play Instant was a way to deliver native Android apps without the installation to your users. So that if someone clicks on a link that would normally open a deep link into your app, had the app been installed on the device. But now that would work without actually the user installing the app. So let's say you have some kind of newsreader and you have a website with the news articles, and if the user with a compatible device clicks on a link to a news article, instead of launching a web page, it quickly loads a small instant app version of your app and shows that in a native Android way. Now, there were some pretty stringent requirements to make an instant app. So you had to support runtime permissions. There were a lot of API restrictions when it comes to things like content providers and services and notifications. And the two probably most difficult things were you had to support app links, which is a way of verifying a deep link through putting a file on your website on a domain that you control. And that was pretty tricky. Many developers were struggling with actually doing that correctly. And then the even more difficult part was an instant app had to be 4 megabytes or less total for any entry point. So anytime a user clicks on a URL, the APKs that had to be pulled down from Play to launch that native experience had to be 4 megabytes or smaller. And I put asterisks next to these 2 points because that's actually changing now, and we're making it easier for developers. So starting, I think, with this year's I/O, app links are no longer a requirement. You can actually have an instant app that doesn't even have URLs, so you don't need deep links. There is a new Try Now button in the Play Store, and you can also direct people to your instant app from ads. And the other thing is we have a 10 megabyte beta program for apps. So now the restriction will be 10 megabytes. Okay, so how do you actually get from an app to an instant app, to this new way of letting your users instantly interact with your native app? Well, normally you start, like we discussed, from a monolithic APK. Where you have all your code, all your resources, basically everything in your app in a single APK that gets delivered to your user's device. But probably in your project, in your Android Studio project, you have some kind of modules. You architect your app, you partition it into separate modules. You probably have some common library that all of your app depends on with things like networking or image loading, stuff like that. And then you can also partition your app into features. So let's say, going still with the newsreader example, you can have a feature for the news index, you can have a feature for the detail view, you can have a feature for an image gallery that's attached to an article, let's say. So if you could identify, both from a UX perspective and from your project like development perspective, a feature that can be self-contained and used as a single thing that a user can use in your app, such as reading an article. And if you could pull that out and have that as a self-contained section of your app, you could actually have an instant app from that feature. And then you can, of course, identify others, so image gallery and so on. And you can make those feature APKs that will depend on this base APK. And basically, you have an instant app now if you can make sure that a feature plus the base module is less than 4 megabytes. Now, you don't need to have multiple feature APKs. If your app is small enough, if it's under 4 megabytes, you can literally just have the base APK if that handles all those URLs and has the necessary activities and so on. But that's basically the setup that you would be looking at. And yeah, that could be an instant app. So, like I said, one of the most difficult things in instant apps is actually getting down to that 4 megabyte limit. Now, you can use ProGuard or Array now. You can use vector drawables. You can get rid of as many resources as you can, but ultimately, you can still be struggling to reach that limit. And so, for the first time, we actually allowed you to build configuration split APKs that contain only code for or only resources for, let's say, the density or the CPU architecture or even languages for the first time that are supported by your app. And then when a user clicks on a link and the instant app starts loading, Play Store will just pick the right configuration splits for your device and only deliver those in order to run your app. So this is actually the first time splits were delivered to users' devices. And you actually still use that old command that has been there for a long time to generate pure splits and package them into the Instant App Bundle. And so Instant App Bundle is actually a new format it's a new publishing format that you upload to Google Play. A user's device never sees the zip file. It never sees the bundle. It's only used to basically package all the APKs that were generated by Android Studio. So the whole generation happens on your development machine. You package that into the zip file. There's nothing special about that zip file. No metadata, anything. You publish that to Play, and then Play can choose these APKs that you gave it and deliver them down to users' devices. Oh yeah, the changes that I already told you about, starting this year, the limit is a little bit relaxed. It's 10 megabytes, but it's currently in beta. You can have URL-less instant apps, so you don't necessarily need app links, although it's still a good indication that an instant app would be nice to have. And there's this Try Now button on Google Play. And if you're wondering if it's worth going through all that modularizing and making your app smaller just to have an instant app, well, I encourage you to watch the instant app sessions from this year's I/O. There are some case studies with developers where they found that even the installation rate and engagement rate with apps goes way up if you also provide an instant app. So it's a good opportunity. And finally, we're getting to the Android app bundle that we announced this year at I/O. So this is a completely new publishing format. So similarly to the Instant App Bundle, it's what I call a publishing format. It's the thing that you upload to Play. It never reaches users' devices. It doesn't have to be supported by Android framework on the device. The device still sees APKs. However, the AAB format, the Android App Bundle, is a better evolution of the APK when it comes to uploading to Play. So it preserves some module information. It has a lot of metadata about all the stuff that's in there, about the resources, the native libraries, and about the targeting of these resources, so which devices it should be installed on. And it works together with a feature of Google Play, which is called Google Play Dynamic Delivery, which takes those AABs, those bundles, and uses the metadata embedded within to actually generate the required splits for you, so you don't have to manage these tens of multi-APKs, or you don't have to generate the APKs on your development machine and upload them. And then it optimizes all these APKs for all the devices that Play Store supports. Using split APKs for L and above. So like I said, splits were supported from Android 5. And then it can even support devices below that using the old multi-APK. So it can fuse all of the splits together into one APK and still support these older devices. And currently, it optimizes your app by splitting on ABI, density, and languages. And for languages, it actually is smart enough so that if you change your language at runtime, if the device is connected to, has an internet connection, it will pull down the new language and replace it on the fly. If it's not, then the user will be stuck for a little while with the old language until a connection is established. So this is how an app bundle looks. Like I said, so maybe you see that? Yeah. Okay. So like I said, it preserves a little bit of module information. So here we have the base module that basically has our whole app. And then there are these things here called dynamic features, which I will talk about in a sec. And then if you notice the assets, resources, and other stuff here, it's actually a new type of file called PB. I mean, it's not new. It's just a proto buffer, which were used for many other things before, but it's new to Android app distribution. So previously we had the resource table in the binary format. We had resources in the XML binary format as well. This time this is in kind of like an intermediary format, so it's easier to ingest and transform and actually generate the split APKs afterwards. And then we have all the resources and so on. So it's a little bit different than an APK. There's no easy way to actually look into the resources right now. We're working to adapt the APK analyzer so that you can actually inspect bundles. But there are other ways of verifying if everything you need is in there. So what's the migration path for making your app bundle compatible? Well, it's pretty simple. You build a bundle. Then you enable play signing on Google Play. So you have to give your key to, for an existing app to play or generate a new one. And you upload a bundle. And so instead of assembling your app using assemble release that builds an APK, you just bundle release. And that's it. There's nothing else you have to do to support bundles on the base level. And you get density splits, language splits, and ABI splits for free. So previously you could specify which type of splits you want using the splits directive. Now you can do it using the bundle directive if for some reason you don't want the Play Store to apply these optimizations. Some of these, you can disable them selectively. This will be put as metadata in the bundle, and then Play Store will, let's say, not generate these language splits or whichever ones you want. But I mentioned there's this other thing here called dynamic features. And so if you were watching the I/O keynote where app bundles were announced, I think they only talked about the app size benefit. But I think the biggest revolution in Android apps distribution and building is that now we can actually load modules of your app on demand. So what people were trying to do for a long time with hacks and so on, we can now actually do using dynamic features. So a dynamic feature, similarly to a feature in instant apps that could be loaded on demand when you hit a certain URL, you can similarly take a part of your app, a feature or a module of your app in your project in Android Studio and mark it as an on-demand dynamic feature. And then that will not be packaged in whenever a user installs your app from the Play Store. It will not be packaged in that base APK. It will not be downloaded to the device, but it will still be ready on the Play Store to be served to your app whenever you require it. And so there's some metadata added to the Android manifest of such a module that tells Play Store that it's on demand only. You give it a title so that it's shown to the user in the interface when you require it at runtime. And then it has this fusing attribute. Now, like I said, for devices pre-L, there's no way of downloading splits or adding splits to an APK. So fusing basically tells Play Store that if the app is installed on a pre-L device, this dynamic feature module should be fused into this single APK and still delivered as part of your app. So how do you actually tell the system or Play Store at runtime that you want to download a feature module? Well, there's a new PlayCore library, or PlayCore SDK, that has two main classes you will interact with. The first one is Split Install Manager, and the other is Split Compat. So Split Install Manager has basically one function. It lets you request modules. So if you named a feature module, let's say picture messages or promotional filters or whatever, or image gallery, at runtime, whenever a user actually clicks on this part of your app, you can request it and tell the Split Install Manager to install it right now. Well, the user will have to wait. This is an opportunity for your UX designers to shine. And of course, you don't want to make every feature of your app on demand, because that wouldn't make sense. But let's say if you have an app where 95% of your users only use the main functionality, such as, I don't know, it's a chat app, so people chat. So, I mean, the basic message sending should, of course, be there. But if you have some kind of stories or filters or whatever, and that's only used by 5% of your users, maybe it makes sense to not include all the native code that's there to support it for everyone, and instead download that on demand. And then if you use dynamic features, there's this other part that you should also include in your app called Split Compat. Now, before I said that splits were supported from L and above. It's actually a little bit more complicated than that. So they were first introduced on L, but they were never used. So there were various bugs or problems lurking in the API. And so on M and on N and so on, they kept changing it a little bit. And so on L and M, if you install a new split APK in your app, you can't actually use the code or resources from it until the app restarts. Now that has been lifted from N and above. However, there are still things that will not necessarily work if you just install a split APK and don't restart your app. The Split Compat API is there to help with that. So even though the problems that we identified were mainly on L and M, we actually encourage developers to always use Split Compat whenever they're dealing with dynamic features, even on Android P. Like, there's always something that we can fix with Split Compat. So it's better if you start using it regardless. And so now you install it in your application startup. You can either extend from a special Split Compat application class, or just add this one line in your attach base context method in the application class. And then whenever a new module is installed on demand, if you don't want to the user to wait until they restart the app, you basically have to create a new context and use that to access resources and assets from the new split. And also, if you're using any native libraries, there's a different command. So normally you would say system load library. This time you have to say split install helper load library. And that's it. Basically, you have to just remember to refresh your context and use the one from the Split Compat. So I said that there are ways to inspect what's in your bundle, even though we don't have the tools for that yet. So the APK Analyzer is not fully supporting the new resource formats. So there's this thing called bundle tool. And that's actually used both on the Gradle side in our build chain to generate bundles and APKs from bundles. And it's also used on the Play Store to generate the splits that will be installed on users' devices. And it's open source, so you can actually download it and run it on a command line. So having this one tool that you can actually use lets you do the same things that Play Store would do locally. So if you give it a bundle, you can generate all the types of splits that the Play Store would and inspect them in the APK Analyzer. So you can make sure all the resources are there, or all your code is there, and so on. And we're also hoping that if you're using any other app stores than Google Play, that they will take this bundle tool and start supporting Android app bundles. Yeah, you can check it out. You can generate, with bundle tool, you can even if you have a device connected via USB to your development machine, you can even save the device characteristics of that device to a JSON file, and then use that JSON file to generate exactly the splits for that device to test it locally. But you don't have to. Google Play also introduced a new internal test track that's available in addition to the alpha and beta tracks in the Google Play console. You can add, I think, a maximum of 100 testers to it. And what it gives you is it basically does instantaneous updates. So if you'd rather have Play Store generate all these APKs and you want to verify on your real device that an update of your app worked and it was working correctly during development, simply upload a bundle or an APK, and within seconds or minutes on this new internal testing track, you will get an update on your device. So you don't have to simulate that locally somehow. So there's a few things now that open up for us now that we have app signing by Play, when Play can hold your private keys to sign the apps and optimize them, and also with the new bundle format. Now, these are some of the things that I will tell you about now. It's not something I'm announcing. It's more my speculation based on the facts that we know right now. So many developers are asking, so how do instant apps and the instant app bundles work now that we have Android app bundles? And yes, we know that right now these are two separate things, but we are working on it. We are working on some way to converge instant apps and bundles so that ideally one day you would upload one app bundle and you could have parts of your app be instant app enabled. But this is still evolving. This is not necessarily going to be true. You might have to manage two bundles. You might have to manage only one bundle. The thing is, we want to make it easy to build both an instant app and a bundle from one project without many code changes, without having to have two separate branches or anything, and then an easy way for you to upload it to Play and have parts of your app instant enabled. But we will talk about that more as this story matures and is ready for developers. Of course, now that we have the key and we can apply optimizations, we could do much more. So right now we have, like I said, ABI density and language splits. But you know, in the future we can look at different texture formats, different OpenGL or Vulkan versions for your apps, and all kinds of different targeting and optimizations we can do inside the APK. Like maybe even optimize DEX code, who knows? But that's just my speculation for now. Yeah. And then one thing that I didn't mention is that if you use an app bundle right now, you can't really use an APK expansion file. Like these were very useful for huge apps such as games. They could have APK expansion files up to 1 gigabyte, I think, that held all the levels, textures, resources, and so on. Well, with app bundles, they're not really supported right now. They might be replaced just by dynamic features. So dynamic features, just like a regular APK right now, are limited to 100 megabytes. So they're not a full replacement for now. But if your game is, less than 100 megs, you could theoretically use dynamic features to load levels or stuff like that. But there needs to be a better story here, and I'm looking forward to for us to have that for you. And then potentially with some of the changes that are coming in Android P when it comes to key verification on device, and also with Play signing, and potentially an APK signing v3 coming in some future, there might be a possibility for key rotation. So that if your key is ever compromised, if you, I don't know, checked it into GitHub without a password or something, and others have gotten your key that should not have it, and it's basically compromised from a security perspective, we could potentially allow for apps to rotate a key and completely change it to a new one. However, that is not ready yet, and I don't know if it will be soon. There's one more thing I wanted to mention briefly because it's related to app distribution on Play. Earlier this year, we announced that starting in August and November, we will stop accepting new apps and then updates to existing apps that are not targeting SDK version 26, that is Oreo, Android 8. And there are a few reasons for it. Mostly it's for users' privacy, security, and for battery life. The latest versions of Android not only introduced runtime permissions, but also had a lot of new restrictions for things like free running services in the background, broadcast notifications, and so on. And developers were very reluctant to raise their target SDK version just to escape from these new restrictions. And the truth is, we're not adding these restrictions to make your job as developers more difficult, but rather to make the whole ecosystem better for users and make their battery last longer, their devices be faster, less sluggish, and so on. And so you will have to adhere to these restrictions soon. So I really encourage you to read on DAC. We have a page that lists all the things that you need to do to be Target SDK 26 compliant, and you should start doing that now. Also, after the session, I'd love to hear from you if there's anything else you would like to see on the Play Store, and I can bring that feedback to the team. And that would be it, except that I also have a few minutes left. So I have a small demo, actually. So yes, this is Android Studio running on a Pixelbook, new this year on Chrome OS. And to show you that it's really easy to build and upload a bundle, here's a sample project. It's like my hobby app. It's a Sudoku game that's on GitHub. And I actually just pulled it down from GitHub. I didn't make any changes. I just made sure that I'm using the latest Android Studio version and Android plugin version. So we have 3.2.0 Alpha 16. I think bundles are available since Alpha 14, but just make sure you're on the latest one. We're iterating quickly. And so I have this new bundle release task. And without any changes to my app, I can build that. It takes a while because I use ProGuard, but I did that before. And so I have a page open here in the Play console. So here I have app signing enabled. You can see that, verify that on the page here. And if I go into app releases, I can see my new internal test track. So that's the one that offers instantaneous updates. And I started preparing a new release. I uploaded the bundle that I just generated. It's literally the same file. But I haven't actually published it yet. So right after I uploaded my bundle here, after I finished browsing my files and uploading it, now I have information about the splits, the configuration splits that will be generated from that APK. And moreover, I can go into the Bundle Explorer on the Play Store and I can inspect all the configurations here and even download device-specific APKs. So if I go and, let's say, pick my Pixel 2 while I can download an SDK 8.1, and I can actually, before even publishing my app, if you want to verify that everything is okay, if you want to have those APK signed by the Play key locally, you can download them from here, which is what I did, and I transferred it to my Android Studio here, and analyze APK. So which one is it? This one. So see, voila, this is the Pixel 2 that I selected. This is a zip file containing all the splits that Play Store generates. And voila, this is the base APK that contains most of my app code. And then because I was requesting a set of APKs for the Pixel 2 device, I also have a very small config XX HDPI APK here that contains my drawables and also the English language. I assume because my Play console was set to English. I'm not sure. However, yeah, it's just one language, just one resource file with the necessary drawables, and then a base APK containing all my code. Just doing this, I saved 17% of size on my app. Now, this is a very small app because it's just 1 megabyte. It doesn't really have anything. However, Play Store will show you those savings here. So for larger apps, this could scale hugely. And so let's try it. Now, this is a live demo, so I'm not sure what will happen, but let's do edit release, review, and start rollout. And let's see if it's really instantaneous. Now, there's a few things that can go wrong. One, I never tested this app with an Android app bundle. Two, I will try to run it on a Chromebook on Chrome OS. And I have no idea if the internal test track works with that. So let's give it a few minutes or a few seconds, and let's start up Play Store. Updates. There it is, instant. So right after I uploaded it to the track, I can install it and test it with my team at work or with the client and so on. And if I open it, there it is. Alrighty, so that's it for me. If you have any questions, I think we still have 5 minutes. Thank you.